Hi, I'm Jeff Applebaum. Welcome to the Cadence Innovation Theater at the 58th Design Automation Conference. In this video, we begin with Senior Vice President Sanjeev Agarwala with on-edge and on-device AI compute. We conclude by highlighting the latest in autonomous driving. And now, here's Sanjeev.
Hello everyone. I'm excited to be here with you all to share our perspective of how we can help enable AI everywhere and for everyone. If you look at the market requirements as we look from sensors to wearable hearables to mobile, IoT vision and ADAS platforms, really it revolves around the careful balance between performance, power, area and workload. And the needs are very dynamic depending on the market applications. So the domain-specific nature of AI solution is very, very critical. And as we look at the performance, it varies from sub-1 TOPS all the way to hundreds of TOPS and latency. And in performance, really, it's all about network performance and not peak TOPS. Similarly, power has diverse use cases from always-on modes to turbo modes, always-on modes ranging from sub-milliwatts to going in turbo modes where you need much more capability and throughput. Workload interfaces are varying dramatically based on target sensors and workloads ranging from 4, 8, 16-bit to fixed float and multi-mode solutions. And similarly, area is all about TOPS per millimeter square, not just millimeter square. So overall, the needs are really for optimum TOPS per watt and TOPS per millimeter square, not just peak TOPS. From a product perspective, it's about battery life, it's about performance, and being able to continuously evolve the products and offer customers new feature. And as we translate this market and product needs into from an IP and solution perspective, power and cost becomes very fundamental. So from our perspective, when we take these markets and look at what kind of capabilities will be needed, we believe much like it has happened over the last 20 years in terms of domain-specific signal processing as we look at audio, vision, radar markets and other opportunities. Similarly, for AI, we will need domain-specific, configurable and extensible AI solutions. So Tensilica's strategy overall over the years, since its inception 20 years ago, is built on a configurable and extensible processor platform where we offer customers a very easy mechanism to deploy the capabilities of their particular solution in terms of embedded CPUs or domain-specific DSPs, and being able to generate the full hardware and software solutions automated real-time, specifying their solutions in high-level languages. And we offer overall not just the hardware but the software layer in terms of the full tool chain from compilers, RTOS layers, linkers, loaders, debuggers, and this becomes very fundamental for rapid deployment of technology. Now, in addition to our signal processing strength, we are building AI capabilities into this platform with the same mind of being able to offer a much more comprehensive software and hardware configurable solution. So we are adding what we call AI extensions natively into our processor pipelines. And in addition to AI extensions in our pipelines, we are coming up with these AI engines which are based on our sparse compute technology, which can be coupled along with our signal processing pipelines or our embedded CPUs and offer much more advanced AI capabilities. And then finally, we are using all this to build much more complex AI subsystems to offer flagship AI performance. And as I've been emphasizing, software becomes very fundamental in addition to configurable hardware for rapid deployment. So we are paying a lot of attention to the software, particularly in terms of neural network libraries, runtime environments, end-to-end tool chain in terms of network compilers, interpreters, delegates, and all this working on AI workloads and open frameworks like PyTorch and TensorFlow, etc. So from my overall strategy point of view, from an AI rapid deployment, we are segmenting our approach into three-pronged strategy. First, we are calling it AI base, being able to offer AI capabilities more natively in our signal processing pipelines for deployment of customers who are already using our signal processing capabilities. And then we are offering the capability, in addition to base, when you need more advanced AI capability, couple that with a sparse compute engine, what we are calling AI engines, which can be very quickly plug and play along with our DSP of choice. And then finally, we are putting this, what we call AI Max, where we are using our scalar vector processors, adding ISA extension capabilities, adding AI engines, and being able to build multi-core systems with security and memory capabilities to be able to offer more flagship targeted AI solutions optimized for target applications. And again, software becomes very, very fundamental to go along with it for ease of use and time to market in terms of deployment. In closing, as we all can see, we are moving from numerical to an environmentally aware autonomous computing era. We will see AI needs at every performance, power, and cost point, and rapid deployment will become fundamental to take advantage of the technology. To be able to rapid deployment, we believe we will need a comprehensive hardware and software platform to handle all workloads and markets. Overall, our strategy is to build AI on our extensible and mature Tensilica platform and help enable take AI everywhere and for everyone. Thank you.
This is the first digital radar chip in the world, and it'll be the first of several million.
Under is a company that focuses on automated driving and basically making the roads safer. And we do that through making the world's best radar system.
What it'll do is it'll make interference a non-issue, greatly increased angular resolution, and what I call high contrast resolution. A child next to a truck, a bicyclist next to a guardrail, or a motorcyclist next to an SUV.
At UNDA, we're working on this new exciting radar technology. We are focusing on this high level of integration onto a single chip that gives us unprecedented performance.
It's a radar which has at least 16 times more channels than any other automotive radar on the market, either today or coming up in the next 2-3 years.
If you look at the competing sensors that are available in the car, such as a LiDAR, they're very difficult to get ready for automotive qualification.
So if you look at self-driving cars today, some of the challenges they have are the technology is such that if you have a large object and a small object, the large object overwhelms the small object. That's exactly the problem we solve.
Our radars are actually exceeding the LiDAR capabilities of today, both in range resolution, cross-range resolution, so that it really does make a possibility where you have fully autonomous cars.
Our core value is that we took all that technology, the signal processing, the RF, the antennas, the packaging, things that exist but not in a scale that can be brought into automotive form factors, power and cost, and we repurposed the chip to do exactly that.
As a startup, correct, we're challenged in many ways, and we need a lot of support in terms of understanding how to best use the tools. Cadence has been very instrumental, and we got all the support which one could expect from Cadence.
Some of the technical challenges with Under was really the complexity that we brought to the systems. That challenge of bringing all this capability and this functionality into a single chip, it really wasn't possible without Cadence.
We knew we needed not just a tools vendor, but a tools partner. Cadence was excited by the vision. They understood the implications of this both to our industry and to civilization in general, and they were willing to work with us because we knew we'd need their help when push came to shove. Those tools that have to be reliable, trustworthy, and rock solid, those are the kinds of tools Cadence gave us. We know Cadence, they know that we are going to be successful in the automotive space, and together we're going to save millions of lives.
Hi, I'm Arif Khan, Product Marketing Director at Cadence. Welcome to our virtual demo at PCI SIG DEF CON 2021. I/O bandwidth doubles nearly every 3 years. Staying ahead of this curve, the PCI specification has evolved and kept pace, and we're on track to ratify 6.0 this year. Cadence has been an active contributor to the SIG, and today we'd like to show you a few demos and highlights from our complete portfolio of IP and verification products that span all the way to PCI 6.0. Cadence IP for PCIe is designed for a wide application space and is extremely feature-rich. Our latest IP offerings for PCIe 6.0 bring together our silicon-proven PAM4 solutions with our years of PCIe expertise. The Cadence PAM4 solution demonstrates BER exceeding the PCIe 6.0 specification at 42 dB insertion loss, demonstrating the robustness of the base technology. The TXI shows good linearity. Cadence's controller IP for PCIe 6.0 builds on a legacy of high-performance architecture, bringing quad-issue superscalar design compared to standard PCI designs providing the highest performance at the lowest latency. The controller simulation shows EQ bypass to the highest rate going from 2.5G to 32G to 64G and then Gen 6 L0, and also shows legacy mode going through all rates from 2.5G to 64G and then Gen 6 L0.
At Cadence, we empower engineers at world-leading semiconductor and systems companies to create intelligent and highly differentiated electronic products that rely on the most advanced semiconductor devices. From consumer products like mobile devices and autonomous driving to next-generation hyperscale computing, the technologies of the future will be integral in our lives and intelligently connected. Electronic design automation, EDA, has always been at the forefront of breakthrough design, driven by advanced computational software, the bedrock of what Cadence delivers. With the explosion of big data and massive computational workloads, it's more important than ever to leverage proven software, computational in nature, that includes best-in-class design, verification, IP, and system analysis capabilities. Recent advancements in silicon design and computational software address these design challenges head-on with an intelligent dimension. The difference centers on select key innovations. Integration and co-mingling of previously independent design, analysis, and implementation to achieve optimal results. Partitioning and scaling of computation to thousands of CPU cores and servers, and the introduction of machine learning to improve and harness design heuristics for system optimization. Cadence, computational software for intelligent system design.